This question says, a rectangular tank is 2 meters tall and filled with water. Calculate A, the pressure at a depth of 0.5 meters, B, the pressure at the base of the tank, and C, the thrust exerted at the base of the tank if the area of the base is 1 meter squared. For questions like these, it's best if you draw a diagram. So we don't know if the tank is cylindrical or if it is rectangular, but I'll just sketch a diagram to illustrate the heights then. So we have a tank, and this tank has a height of 2 meters and it's filled with water. They want us to calculate the pressure at a depth of 0.5 meters. So we consider this is half from here to here is 1 meter, which means a depth of 0.5 meters will be from the surface of the liquid up to this point. So 0.5 meters. So the question wants us to calculate the pressure at this depth. So this is fluid pressure, and we could write that equation to be able to calculate it. So I'll head it up here, that this question wants us to calculate the pressure, and they gave us the depth, which is a height, which is the height of the fluid above the point, or the depth of the point from the surface of the fluid is 0.5 meters. So we can write the equation for fluid pressure. It says pressure is equal to the density by gravity times height, which is equal to 1000 kilograms per meter cube. We could substitute the value for gravity. Acceleration due to gravity 9.81 meters per second squared, and finally the height, which is the same as the depth of the point from the liquid surface, is 0.5 meters. So we'll always work our units first to ensure that we can get units of pressure. In this case, we could cancel m here with m cubed, and we'll be left with m raised to the power 2. Now, it might be a stretch for you to think about this, but consider this kilogram times meters per second squared, and we'll have the Newton. So we know that we'll get Newton per meter squared. Yeah? We can recognize this later on as the Pascal, but for now we could perform that calculation. We have 1000 multiplied by 9.81 multiplied by 0.5, and that gets us 4905 Newton per meter squared. And we know that 1, and we could put this in brackets here, 1 Newton per meter squared is equal to 1 Pascal. Therefore, pressure is equal to 4905 pascals. Now we'll report this to the more appropriate SI prefix of this unit. So that will be 4.905 kilopascals. Now that we have the answer for the first part, we'll look at part B. Now part B wants us to calculate the pressure at the base of the tank. So since the tank is filled with water and the tank is 2 meters high, then the height of fluid above that point will be 2 meters. So the height of fluid above the point at the base of the tank is 2 meters. They ask us to calculate pressure once again, and we know that pressure at any point in a fluid is given by density multiplied by gravity multiplied by height. So we could substitute values. Again, the density of water is 1000 kilograms per meter cube. We'll multiply that by the acceleration due to gravity, 9.81 meters per second squared, and we multiply it now by a height of 2 meters. Once again, our units will cancel. We'll be left with, and I can write it here on the outside, kilograms meters per second squared on meter squared. Yeah, we recognize this as the Newton per meter squared, so Newton per meter squared, and we know that 1 Newton per meter squared is again 1 Pascal, so we'll have an answer in pascals as well. Right, so let's look at that. 1000 times 9.81 times 2. So we'll have an answer here of 19,620. So since 1 Newton per meter squared is a Pascal, this is also equivalent to 19,620 pascals, or 19.62 kilopascals. With answers for both A and B, we now look to part C of the question. It says to calculate the thrust exerted at the base of the tank. If the area of the base of the tank is 1 meter squared. Now the word thrust here means the force, since pressure is thrust per unit area, or perpendicular force per unit area. The thrust is going to be felt at the base of the tank, so it will be a normal force to the base of the tank. So the question wants us to calculate the force at the base of the tank. So the information that we have for this part of the question is that the area is 1 meter squared, and we have to calculate the force at the base of the tank. Now we have the pressure at the base of the tank, and we know the area at the base of the tank. We know that pressure is related to force and area by this equation. Pressure is equal to force on area. So we could transpose this equation for force, and if we do so, we'll get the force is equal to the pressure multiplied by the area. So we could go ahead and substitute. In this case, force is equal to the pressure. Now we're going to write the pressure in pascals. 19,620 pascals, and we are going to multiply it by the area in meter squared. Because we want to work to get units of newtons, we'll write, since 1 Pascal is equal to 1 Newton per meter squared, we could rewrite this equation. Force is equal to 19,620, and instead of Pascal, put the Newton per meter squared, and now multiply it by the 1 meter squared. So we could cancel our units of per meter squared and meter squared, and we'll be left with the Newton. 19,620 multiplied by 1 will still give us 19,620 newtons. So we're going to say that this force is equal to 19.62 kilonewtons.